Hi, this video is going to provide a short overview of the operation, control and power output of the Leixlip Hydro Power Station in County Kildare. It was commissioned in 1948. It's one of 3 hydro power stations on the River Liffey and has a capacity of 4 megawatts. The total head height at the dam is 18 metres and it's fully operated and controlled by the ESB. The main priority of the ESB at the dam is to maintain safe water levels. The dam normally operates between 43 to 45.6 metres above ordnance datum. The flow which you can see coming through the spill gates here is the compensation flow, and Leixlip Hydro Station is required by the national legislation to allow 1.5 cubic metres per second averaged over 24 hours through the dam. The ESB, who maintain the water levels at the dam, will generally put the water through a turbine, and in cases where there's excess volume of water at the reservoir, they'll use the 3 spillway gates to discharge. Located on site, there's hydrometric recording equipment, staff gauges, and there's electrical equipment as well, which continuously monitor the water levels. This clip is just a side view looking over the powerhouse and up at the dam wall. The total width of the dam is roughly 114 metres, and this just looks down onto the tailrace side of the river. The reservoir capacity at the Leixlip Dam is relatively small, especially in comparison to the Pool of Fuca Dam located further upstream. It can hold a maximum of 7.7 million cubic metres of water at a maximum operating head height of 45.6 metres above ordnance datum. This clip just looks over towards the 3 spillway entrances, and in the centre of the picture there's the fish pass entrance also. Just pans around to look upstream on the head race side of the river. This image here just gives you a view of the reservoir at Leixlip. As you can see, it's relatively small. In the background you can just make out the M4 Dublin-Galway motorway bridge. And this image here just shows you the tailrace side of the dam, which is also particularly narrow. The river then makes its way into Dublin City. This image here just shows the fish pass entrance at the dam. It's used by migrating fish who are travelling upstream or downstream. The River Liffey is particularly common for salmon and trout, so it's imperative that the safe pass of fish through the dam is always looked after. This image here just shows you a small little camera which is just located just above the fish pass entrance there, and it's used by the National Inland Fisheries. They use it just to monitor and control fish stocks that are migrating upstream and downstream. This clip here, you can just see the turbulent flow in the river there. The turbine is obviously in operation here. As a reaction turbine, it's fully enclosed in a pressurised chamber, so the water which comes through there is actually from the draft tube is underneath the water surface there. This view here just shows you the general area of the generating hall. You can see the generator in the middle there, and just to the left is the ancillary control equipment. It consists of a mechanical hydraulic oil pressure governor, which is used to maintain a synchronous speed of 300 RPM. Now just to give a couple of quick technical specifications on the main items of plant. The generator is of BBC Brown Bovary manufacture. It generates at 10,500 volts, 3-phase 50 Hz, and it has a normal rating of 5000 kVA. The turbine is manufactured by Escher Weiss. It's of Kaplan type, 5 blades, and has rated horsepower of 5800. The generator has a rated capacity of 4 megawatts and is fully controlled from the Hydro Control Centre in Turlock Hill. In the background there of this shot you can just see the gantry crane at high level, which is used during maintenance procedures of large items of plant. What you can see here is the mechanical hydraulic oil pressure governor. It's used to adjust the position of the wicket gates and the turbine blades to control the oncoming flow and optimise the efficiency. The cabinet you can see here in front of you consists of a flyweight mechanism which operates on centrifugal force and is driven directly by the turbine shaft. An increase or a decrease in speed will cause an output to a valve which operates a servo motor which adjusts the position of the wicket gates and the angle of attack on the blades. This double regulating feature at Leixlip on the Kaplan turbine allows for excellent efficiency over a range of loads. In this image here you can see some of the pressurised oil pipework which runs up to the shaft of the generator and runs down the column right down into the hollow hub of the turbine where the servo motor is located to adjust the blade angle. This short clip here was taken on the turbine floor. As you can see, it just displays some of the oil pipework and the associated control equipment of the speed governor, which continues to be one of the most vital pieces of equipment at the site. So over the course of 2014, the Leixlip Hydro Station had a total exported power output of approximately 14,800 megawatt hours. The best periods of power generation were in Q1 and Q4, which correlates well with the rainfall data at those times. The turbine had an overall annual average efficiency of 73%, and despite generator availability dropping by 3.5% throughout the year, the capacity factor recorded was 42.25%. That concludes this short video. Hope you enjoyed it, and thanks for watching.